So the last section was the first relationship that we have between sets. We talked about what it meant for something to be a subset. There are other relationships, and we're actually going to derive a set of a few operations that we can do with sets so that we can have as much fun as we possibly can. And so in order to do these operations, we use a tool, and you can see a bunch of them on the sheet that I gave you. A tool to illustrate the relationships between sets is called a Venn diagram. Okay, the word Venn has two N's, and then diagram. Venn is the name of the mathematician long, long ago in a galaxy far, far away that actually started the area of math called set theory and made these drawings to be able to look at them. So before we get into what a Venn diagram is and before we get into using them, I just want to label a couple things right here. The first thing is that this box that is surrounding my Venn diagram represents what's called the universe. The universe in any particular problem is everything that's being considered. Now, I know we tend to think of universe as something really big because it's the planets and the stars and the galaxies, but the universe, as far as sets are concerned, doesn't have to be particularly large. It can be any size. It can be 10 things, it can be 5 things, it can be a billion things. It just depends on what it is you're talking about. And so what you'll tend to see when you are looking at problems and you're going through your homework is the outside of the Venn diagram, there'll be a U that's put up in the corner. That is reminding you that whatever's in the box represents the universe. And each circle represents a set of objects in the universe. And so normally, I'm going to write the word set in front of these just so you have it for your notes. But normally what you'll see is this circle will just be labeled A to represent set A. But I'm going to write the word set in here so that later on when you're reviewing, you know what you're looking at. And then the other circle we'll just call set B. Okay, so A and B. And they will have objects in them when you're looking at the picture that are part of the universe. So the first of our set operations is going to be called the complement of a set. Okay, now the way complement is spelled here, this is not saying nice things about the set. In this case, what the complement is referring to is the following. The complement of set A is everything in the universe not in set A. So when you're asked to find the complement of something, you're asked to find what is everything else outside of the set. Now I'm going to illustrate this on one of our Venn diagrams. The complement is the only one of our set operations that only requires one set. So I'm going to label this left-hand circle set A. And then of course my box is U, so I'll put a U up there. And so I'm just going to now shade in what represents the complement, what represents everything that's not in set A. And so this circle, this whole left-hand circle, don't worry about the right-hand one, it has nothing to do with the complement. This whole left-hand circle is set A, so the complement is all this stuff outside. So I'm just shading outside the circle A. So you should have the complete set A that is white, and then everything else outside is whatever color you are shading, probably pencil color. So the symbolism for our complement is you'll see whatever set it is, in this case A, and then a little apostrophe. Our book uses an apostrophe, other books use a line over the letter. It really does not matter which one, but we're going to stick with our book's notation. So A apostrophe, that is saying to you, find the complement of A. Now I'm not going to quiz you on this next part, but I just want to remind you, we talked about in the last section, or excuse me, last time in section 2.1 about the idea of set builder notation. So I'm just going to show you just for fun and trivia, and you can impress your friends with this when you go home. This is how you would write the complement in set builder notation. You would say that it's the set of values x, like we were talking about last time, such that, and here are the characteristics. My value is in the universe. Remember this E without the corners, that is element of. So X is an element of the universe and X is not an element of A. And there's the set builder notation for that. Again, I'm not going to quiz you on that. I just want you to see that this tool, this skill that we talked briefly about does have application beyond where we were. You with me so far? The complement is everything in the universe outside of your set. Well, before we go to the next operation, let's apply this. So I'm going to flip to page 3. On page 3, I have defined a problem for us that we are going to do a whole bunch of. This is going to help us get acclimated to these operations. I've defined a universe, a nice, small, relaxing universe, so it's not too much trouble for us. The universe is the numbers 1 through 10, the natural numbers 1 through 10. I've defined set A to be 1, 2, 3, 8, set B to be 1, 3, 6, 7, 8, set C is 1, 3, 4, and finally D is 5, 7, 9, 10. So up here, I'm just defining the constraints of the problem. I'm going to do example 1. Example 1 says, let's find the complement of A. Well, the complement, as I just mentioned to you, is everything that is not in the set. So if my set is 1, 2, 3, 8, and my universe is all the numbers 1 through 10, then here we go. Let's go for it. The complement is everything that's in the universe that's not in the set. So is 1 going to be in my complement? No, 1 is in the set. Is 2 going to be in the complement? Is 3? No, those are all in the set. Is 4 going to be in the complement? Yes, because 4 is not in the set. How about 5? Yep, and 6, and 7. 8 is in A, so I'm going to skip it, and then 9 and 10. By the way, I mentioned earlier with the letters, the reason that I usually go alphabetical order or number order is just when you start to do problems, it helps you see where everything is. Okay, so it's not a requirement. I will not mark you wrong on the test if you do your order different. It's just, in my case, it's for my sanity. Okay, otherwise I would go crazy looking at all of these different numbers. A nice way to check yourself with the complement is when you smush the set A and its complement back together, they should add up to the universe. So you should have between A and its complement, you should have everything in the universe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the whole universe. We are good. You with me? You see how we got the complement out of that? Awesome. You're doing fantastic then. I really appreciate it. If you would please, exercise 1 says do the same thing with set B. Find the complement of B. All right, set B up at the top is 1, 3, 6, 7, 8. So the complement is going to be everything in the universe. That's not one of those. So 1 is not going to be in the complement, but 2 will be. 3 is in the set. So then 4 and 5 are the next ones in the complement. 6, 7, 8 are all in the set. And then 9 and 10. So we should all be looking at 2, 4, 5, 9, 10. Does anyone have something different in your B complement and you don't understand why I don't have it? One more time for good measure then. Find the complement of D. Set D is 5, 7, 9, 10. So the complement is going to be 1, 2, 3, 4. And then not 5, and then 6, and then not 7, and then 8, and then not 9 or 10 because they are in the set. So we should all have those 6 elements, 1, 2, 3, 4, 6, 8. We still doing okay? All right, I'm going to go back to the front page then. Okay, the next operation of the sets. We talked about the complement. That is the first of them. The second one is going to be the idea of what's called the intersection of two sets. When you use the word intersection in just everyday language, when do you use the word intersection? Driving. When what happens? Two roads cross, right? Where the roads cross over, that's called the intersection. Well, it means the same thing in sets. The intersection of set A and set B is the set of elements in both A and B. It's where they cross. It's what they have in common. On my Venn diagram, here's my universe. I'm going to have my set A and I'm going to have my set B. And then I'm just going to shade set A and I'm going to shade set B, and then we're going to see where they cross. Now, you probably don't have different colors. So what I would encourage you to do is shade each a different direction to distinguish them. So for instance, I would shade set A up and to the right like this. Okay, that's what's red on mine or shaded up and to the right, that represents everything in set A. And then I have different colors, so I'll use green, but since you don't have different colors, shade down and to the right this time. This represents everything in set B. And then again, the whole purpose of Venn diagrams is so that we can picture where these are, so that we don't always have to shade. Where am I going to shade? Where's the final result? Where do these two things overlap? Yeah, in this middle, this eyeball shaped thing in the middle. So I'm just going to shade this a little darker. And this that I'm shading darker is where A and B intersect, what they have in common. The symbol for the intersection you can see is A. It's an upside down U. Okay, but it's not a letter U. Be careful. That's why I've been trying to put a tail on my universe U to distinguish it. I don't want you to think that this is the letter U, but it looks kind of like one. Again, this part I'm not going to quiz you on, but just so that you know how set builder notation would come into play, that the intersection is the set of values X such that X is an element of A and X is an element of B. It's in both. Once you're done writing there, let's turn over to page 3 again. We're going to do a couple problems with this before we do the next operation. So I'm going to do example 2 where we were. We're using the same sets as before. So if you're watching on video, I'm not going to be able to get the whole thing on the screen. So make sure you have this printed out or you've written down what these sets are. So push pause if you need to. So what we're going to do is we're going to intersect A and B. So again, where do they overlap? So looking at A is 1, 2, 3, 8, and B is 1, 3, 6, 7, 8. What elements do they have in common? They have a 1 in common. They have a 3 in common. And an 8 in common. That is the intersection of A and B. Anyone have a question, like you're thinking another number should be in there or something shouldn't be? Please speak if you need to. Well, given that, then go ahead and do exercise 3. You're going to intersect A and C. A is the set 1, 2, 3, 8. C is 1, 3, 4. So where do those overlap? What do they have in common? Yes, 1 and 3 are the things that those two sets have in common, and nothing else. We still okay? Please do the next one. D intersect B. D is 5, 7, 9, 10. B is 1, 3, 6, 7, 8. What do those two things have in common? Okay, just the value 7. Excellent. I like all the voices. Does anyone have a question before I have you do one more? All right, the last one we're going to do, then we're going to go to the next operation, is C intersected with D. When you look at C, which is 1, 3, 4, and D, which is 5, 7, 9, 10, what do those have in common? Nothing. So it is the empty set. Set with no elements in it, our empty set. Before I move on, that's the intersection. Anybody got a question, comment, or concern about the intersection? All right. Then let's flip to page 2, where we'll find our next one. We've got the idea of a union. A couple places that we would use the word union. If you work somewhere that has a union is just a group of people. Okay, when people get married, it's called a union. It's two people coming together to become one unit, I guess. So the union of sets is the idea of, we're going to take set A and set B, and the union of those sets is everything that's in either set. Okay, so the union of set A and set B is the set of everything in either set A or set B. And the symbol for the union is, again, this U looking thing. No tail on it. It's not a letter U. It's just the rounded symbol that looks kind of like a U. And so on my Venn diagram, here's my universe. I'm going to label set A and I'm going to label set B. And then the union is just everything in either of those circles. Any element that would fall in either one of them is part of the union. Again, this next part, this is not part that I'm going to quiz you on. I'm just showing you that set builder notation is part of this, part of the underlying structure. The union is the set of elements X such that X is an element of A or X is an element of B, one or the other. Notice it's not an and means both as far as sets, and when we turn our attention to logic in the next chapter, and means both, or means one or the other. We good? Everybody caught up? I don't want to go too fast. Am I going too fast? All right, then going to page 3, we're going to do a couple of examples with the union. So mine's going to be A union B. So A is the set 1, 2, 3, 8. B is the set 1, 3, 6, 7, 8. And so again, I like to go number order. If you put your values in a different order, that's not wrong. I won't mark it wrong. So I've got 1. Now notice 1 is in both sets. You only write it once. Okay, you don't write it twice. Okay, so 1 and then 2 is in set A. 3 is in both sets. You only write it once. 6 is in set B, 7 is in set B, 8 is in both sets, but you just write it once, and there's my union. I've taken the two sets, I've merged them together into one set. If you would please do the same thing with B union D. B union D. Set B is 1, 3, 6, 7, 8. D is 5, 7, 9, 10. So 1 is in B, and then 3 is in B, 5 is in D, 6 is in B, 7 is in both, but you just write it once. 8 is in B, 9 is in D, and 10 is in D. And there we go. There's B union D. Please do the same thing for C union B, just to get the feel for it. You're just about there. So C is the set 1, 3, 4. B is 1, 3, 6, 7, 8. So here we go. 1 is in both. 3 is in both. 4 is in C. 6 is in B. 7 is in B. And 8 is in B. And there is our C union B. Now, the next one, exercise 8, combines a couple of the operations, and in fact, we're already halfway done, but we're going to do a couple that combine the operations just so that you're not intimidated. Once you know how to do the basic operation, if we combine them, it's no different. Just take it one step at a time. So exercise 8 invites you to find B union D, and then that's in parentheses, and then the apostrophe outside means the complement of that. Now, good news is we've already done B union D. You can still see it on the page. It's right there. So if I gave you this problem on the test, that's what I would tell you to do. Remember, just like arithmetic, do the parentheses first, and then you work your way out. So we've done the B union D. Now, if you would just do me the favor, find the complement of B union D. All right, B union D is in exercise 6. It was 1, 3, 5, 6, 7, 8, 9, 10. The complement means everything that's in the universe that is not in that set. And so what elements are not in B union D? 2 and 4, and then 5, 6, 7, 8. Yep, that's it. Great job, everybody. Love it. So one more. I think actually you've done a part of this one as well. The next one says, okay, find A union B and then intersect it with the complement of C. And I think we've already done A union B. It's part of example 3. So what remains for you to do is first, you've got to find the complement of C, and then you're going to intersect those two sets together. So the way you might notate this is I might just go out to the side and write down what C complement is out here, and then intersect that with A union B. Set C is 1, 3, 4. So the complement of that is everything that is in the universe that's not in C. So that's going to be 2, 5, 6, 7, 8, 9, and 10. That is the complement of C. And now from above, I'm going to slide it back into the screen so we can see it. Oh, there it is right here. Example 3. From example 3, we know A union B is 1, 2, 3, 6, 7, 8. So now the answer to my question here is going to be the intersection. I'm just going to put an arrow. That's what we're going to do with these two sets. We're going to intersect the A union B that we had from the previous problem to the C complement that we just found. And what do those have in common? Well, they have the number 2. Is there anything else they have in common? 6 and 7 and 8. There you go. 2 and 6 and 7 and 8. Yes.
So our answer would be just the 2, 6, 7, 8.
That's the final answer. Yes, but we needed the C complement to get there. So that's why I did it off to the side. Great question. Any other questions? All right, so here's what we're going to do. We have 2 more operations, but I don't want to rush through. So we're going to flip to page 4. And we're going to just get familiar with the Venn diagram, and we're going to do a couple last problems with the operations that we know how to do. So I've given you a Venn diagram, and here's what I would like, how I would like you to label it. We're going to put different elements into this Venn diagram. So in this part out here, I'm going to put an A and an I. In the eyeball, I'm going to put an F and a C and a J. On the right side of it, I'm going to put a D, a G, an H, a K. And then last but not least, in the square around it, I'm going to put a B and an E. And there's a problem that I forgot to type on this. So I'm going to, before we do any of the others, what I would like you to do first is I would like you to list what U is. So you can see, I'm just going to go alphabetical order. Again, if you didn't, that's fine. So it starts with, we've got an A in there, and then there's a B outside, and then a C, and a D, an E, F, G, H, I, J, all the way to K. So the universe is the letters A through K. So next, what I'm going to tell you is the circle on the left, I'm just going to call set A. The circle on the right, I'm going to call set B. So the next thing I'd like you to do, again, we're just getting familiar with the Venn diagram and where things are. I want you to find set A. List out the things that are in set A. So everything in set A, there's no other constraints given. So hopefully what you wrote down is everything that is in circle A, which is going to be A and C and F and I and J. That's the stuff that is in set A. Next thing, if you got a question, ask it. If not, we're going to move on to the next one. Write down what is in the complement of B. So you can just cover up the set B with your thumb, that whole circle right there, and then everything else is just the complement. And so the stuff that forms the complement is A, B, E, and I. You tracking along with me? Anybody got a concern? Write down what the intersection of A and B is, please. The intersection is where they overlap, what they have in common, that's the eyeball. And so what we have in there is the C and the F and the J. Two more, and then we are going to call it a day. The next one is you're going to list out what is in the union of A and B, please. So the union is just everything in those two circles, again, in whatever order you want to write them down, but I'm going to go alphabetical. So we've got A, C, D, F, G, H, I, J, and finally K. Last one for us. You have A union B, but see if you can identify this on the picture. What is A union B complement? Where do you find the stuff that is the complement of A union B? The stuff that is, yeah, the stuff that's in U that's not in A union B. Great, write it down and we will be done. So the complement is anything outside, kind of what we would call the border if this was a puzzle. And so it's just going to be B and E.